Hey guys, here's the review for Spiral 23. We're going to start out with exponential and log graphs. We've got an exponential function. This is negative 3/4 times 4/3 to the x power minus 1. And what we're going to do is to identify some points of interest on here and then work on some asymptotes. I see a minus 1 at the end, so I'm going to draw on my asymptote first. That's at y equals negative 1. And for points, to plug in for x, I might choose negative 1, 0, and 1, which is going to end up making that exponent negative 1, 0, and 1 because it's just x as an exponent. First one up, negative 3/4, 4/3 to the negative 1, minus 1. That's going to make this into negative 9/16 minus 1, or negative 25/16. Okay, so that's going to be the point that is something like this. It's a little bit less than negative 1, but not quite to negative 2. Next up, I'm going to plug in 0. Negative 3/4. 4/3 to the 0 is 1. Minus 1 would be negative 7/4, which is not quite negative 2. And then if I plug in 1, we're looking at negative 3/4 times 4/3 minus 1, which is negative 2. This graph would be something like this in terms of a shape. For a second one, we've got to make an equation for this graph. And we've got a few points here. We've got 0, negative 7. We've got 1, comma, negative 2 pi minus 5. And we've got 2, comma, negative 2 pi squared minus 5. What I'd like us to notice is that we can use the same strategy for any points, no matter how crazy they look, even if they look as crazy as the ones we have here. A lot of people were freaking out in the last spiral with that E, but these almost end up being easier because there's less actual math to do. I'm going to use my intercepts first. So, actually, the first thing I'll do is get this asymptote in there. My asymptote looks like it's at negative 5. So our equation is going to start as y equals ab to the x minus 5. Next, I'll use my intercept. Negative 7 equals ab to the 0 minus 5. I'm going to add 5 to both sides, so negative 2. ab to the 0 is just 1, so a equals negative 2. My equation is now y equals negative 2 b to the x minus 5. I'm going to plug in my next point. So we're looking at negative 2 pi minus 5 is equal to negative 2b to the x minus 5, and x is going to be 1 for this problem. I'm going to add 5 to both sides, and I get negative 2 pi is equal to negative 2b to the 1, which means that if I divide it by negative 2, I get pi is equal to b. My equation is going to therefore be y equals negative 2 pi to the x minus 5. And again, I'd like you to note that we didn't do anything different because we had a weird number here. Whether it's a number like e or pi or something in terms of crazy decimals, the method will be the same every time. Next up, we got some conversions and then some evaluations. So first off, we're going to convert from exponential to log form. That's going to use our principle that the log of base b of some answer is equal to an exponent, which is an equivalent expression to saying a base to an exponent is equal to some answer. At this point, you need to have this committed to memory. If you don't, this is worth spending time practicing on, because this will give you this entire page. If you don't know how to do this, you will not be able to do anything on this page. Okay, first things first, we're going to convert. Here's my base, my exponent, and my answer. So in this case, that's going to be log base 5, that's my base, 1 over 125, that's my answer to the exponential, is equal to -3. That equation is done at this point. For the next one, 81 is my base, 3 over 2 is my exponent, and 729 is that answer. So log base 81 of 729 is equal to 3 over 2. For number 13, we've got to evaluate some logarithms. In doing this, we're going to use kind of a similar setup to figure out what's going on here. Two times log base 2 of 64. Well, for log base 2 of 64, I'm going to convert this to exponential. So 2 to some power equals 64. That power is 6. That means that log base 2 of 64 is 6. 2 times 6 is going to be 12. Negative natural log of 0. Well, let's convert this to something that's a little bit easier for us to read, which is log base e of 0. And then we're going to write that as log base e of 0 is equal to -x, just to kind of get rid of that negative. That means that e to the -x is equal to 0. And in this case, there's no number that I could plug in that makes a positive number equal to 0 when I raise it to a power. So this would be undefined. In fact, the log of any 0 value would be undefined. There's never going to be a log that gives an answer from 0. For number 14, we got to solve some equations. If I have everything is exponential, and in this case I do, and everything fits into a nice happy pattern, in this case they do, by that I mean they can all be written as powers of the same base, we can do this in terms of just exponentials. So I'm going to rewrite this all as base 2. All three of these numbers are powers of 2. 128 is going to be 2 to the 7th to the 5x minus 3. 16 is going to be 2 to the 4th to the 2x minus 4. And 4 is 2 squared to the 3rd. I might simplify these exponents next, so we get 2. 7 times 5x is 35. 7 times 3 is minus 21. We've got 2. 4 times 2x is going to be 8x. 4 times negative 4 is minus 16. And then 2 to the 6. I might further simplify that if I realize that if I'm multiplying two things with the same base, I'm going to add those exponents. So we got 35, it should be an x. X minus 21 is equal to 2 to the 8x minus 16 plus 6 is negative 10. At this point, I have my bases the same. That means I could rewrite this as just the exponents. So 35x minus 21 is equal to 8x minus 10. Bring the 8 over, bring 21 over, and we get 27x is equal to 11. X equals 11 over 27. For number 6, even just seeing that e there means to me I have to use logarithms. I could take this a step further and think that I don't have things in the same base. So in that case, the first thing we try to do is to get this exponential expression by itself. Get a minus 5 to both sides, and I get 6 times e to the 2x minus 1 is equal to 14. Divide both sides by 6, and I get e to the 2x minus 1 is equal to 7 over 3. I'm going to convert this to log at this point. For an e, I know that ln of something is equal to log base e of that something. So this is going to be natural log of 7 over 3 is equal to 2x minus 1. If you had written that as log base e, that's fine as well. Okay, I'm going to add 1 to both sides. We get ln of 7 over 3 plus 1 is equal to 2x. Divide both sides by 2, and I get my final answer. ln of 7 over 3 plus 1 all over 2 is equal to x. Next up, we got some exponential models and log models. We're going to have to write some equations and use that to solve some problems. So Mr. Powers bought his house at $216,000 in 1985. Okay, so that's like my starting amount. The value of the house increased by approximately 2% each year in 2008, or until 2008. So we got to figure out what's going on for that part. So final value is equal to starting value multiplied by some kind of a rate to the number of years. Okay, so we've got final value is 216,000 times 1.02, that's 2% increase. And from 2008 to 1995 is going to be 1523 years. I'm going to plug that in to my calculator. And by my calculator, I mean I'm using Desmos. That's what I have in front of me. So I've got 216000 times 1.02 to the 23rd. And I get in 2008, we're looking at $340,610. And a little bit of change, but that's less important for this. Okay, from 2008 to 2012, that's 4 years. The house depreciated by 8% each year. Okay, so for 2012, that's clearly not 2012, we're looking at a starting value of 340, 610, that's supposed to be a colon, times, and 1 minus 0.08 would be 0.92, and that's 4 years. So we're going to take that value, so 340,610, and we are going to multiply that by 0.92, that was 1 minus 0.08, and do that to the 4th power. And we get $244,010. Okay, from 2012 to now, let's go on to $300,000. So let's set up our equations. So 300,000 is equal to a starting value of 244.10 times some rate And from 2012 to 2017, that's 5 years. I'm going to divide 300,000, divide by 244010, and I get 1.22. Let's go 1.2294 is equal to r to the fifth. To get the r by itself, we've got to take the fifth root of both sides. And the fifth root of 1.2294 is going to be 1.04. So that would be a 4% increase on Mr. Power's house since 2012. Next up, we've got a Half-Life problem. We had a shortcut for Half-Life formula where we had the final amount is equal to the starting amount times the half-life ratio, which is a half for a half-life, to the power of time divided by the half-life. Usually we use a lambda symbol for this. But you can use whatever you'd like, so it's half-life. So in this case, we're looking at 3 minutes as the half-life. That tells me that time is in minutes. 78 grams, that's my starting value. And then I look at 7 a.m. as my time equals 0. Okay. So this is given to us so that we can figure out a way to deal with how much time has passed since 7 a.m. So 8:15 a.m., if there's 60 minutes in an hour, 60 plus additional 15 would be 75 minutes. Okay, plugging this in the equation, we've got our final value, or accumulated amount, is 78 times 1/2 to the power of 75 over 3. And in plugging these values in, so that's 78 times 0.5 to the power 25. And we get 0.0000232 grams, which is effectively nothing is left at this point of the day. How long would it take to have only 1 gram Butterworthium? So we're looking at 1 is equal to 78. 1/2 t over 3. You can divide 1 by 78. It's equal to 1/2 to the t over 3. And the only way that I know how to do this right now, based on the amount of math that you guys know, is to take the log of 1/2 of 1/7, and that's equal to t over 3. Okay, so we have to deal with a log base. Sorry, I just have to clear some stuff out of Desmos. And log base 1/2 of 1/7. We get 2.807 is equal to t over 3. Multiply that by 3. And we get t is equal to 8.422 minutes. And that's totally wrong because I did very beginning. I divided wrong. Instead of 1/7, that should be 1 over 78. I don't know if I said that and just didn't write it. But that's going to change that to 1 over 78, which instead of 2.8 something would be 6.2854, which means that my actual time, instead of being 8 something, is going to be 18.856 minutes, or 7:18 a.m. and 856 over 1,000. I could convert that into seconds. In fact, I'm going to, if I multiply this by 60, because this is in terms of minutes, and it's going above and beyond. So it's 7:18 and 52 seconds. Actually, 51 seconds. I lied. That's fun. We've got some right triangle trigonometry. We've got to do some trig stuff, like using values to get other values, and then we've got to use some applications. Starting off, we're looking at cosine of x is equal to 6/12, so I'm going to draw myself a triangle. And I might even reduce this to get 1/2 to make my life easier. I like choosing my bottom angle to be x. So this would be 1 over 2. If I Pythagorize, this side turns into the square root of 3. And the cotangent, in other words, the adjacent over the opposite, is going to be 1 over the square root of 3. If you wanted to rationalize that denominator, you have to multiply the top and bottom by square root of 3, and I get the square root of 3 over 3. For the next one, tangent of beta, I'm going to draw a triangle and make my beta. We got 12 over 5. This is a 5, 12, 13 right triangle. Sine of beta is going to be 12 for the opposite over hypotenuse, 13. If secant equals 30 over 18, in other words, 15 over 9, in other words, 5 over 3. So we're looking at, there's my theta. Secant goes with cosine, so this is 5 over 3 for hypotenuse over adjacent. Cosine, oh man, I could have just done the reciprocal because that's just 3 over 5 for adjacent over hypotenuse. If you recognize that secant and cosine are reciprocals, you don't have to do any of that work. The sun is at an angle of elevation of 58 degrees. A tree, that's my tree, casts a shadow 20 meters long on the ground. How tall is the tree? We're going to assume the tree comes out of the ground at a right angle. So we care about our opposite and our adjacent. And for that, I'm going to use tangent. 58 is equal to question mark divided by 20. Our tree is 20 times the tangent of 58 tall. If you absolutely must have an answer, 20 times tangent the answer for this would be 32 feet tall. Next up, we got a person standing 17 miles from the base of a tall mountain. So 17, that's the tall mountain. There's 4 degrees. I guess I could figure out how tall the mountain is. And for that, again, I'm going to use tangent, which would be tall divided by 17. The mountain is 17 times tangent of 4 tall. So if I do 17 and tangent of 4, I get that tall is equal to 1.188 miles. For the second part of the problem, when they move 12 miles closer, so now that's 5 because 17 minus 12 is 5. What will be their angle of elevation? I'm looking for that angle when they look to the top, so 1.188. So if tangent of theta is equal to 1.188 divided by 5, that means that arctangent, or tangent inverse of 1.188 over 5 should give me that angle. And let me see if I can do that on here. So we want arctan of 1.188 divided by 5. We get an angle of 13.365 degrees is equal to theta. Okay, next one. So given sine of theta is equal to 3/4, I'm going to just draw that in here. So 3 over 4. Rather than label this a different guy up here, since they have 180 in the triangle, I'm going to say this angle is 180 minus 90 for the right angle, minus theta, or 90 minus theta. And oh look, that's what we're trying to find. So we want cosine of this angle. Cosine of 90 minus theta happens to be the same thing as sine of theta, or 3/4. Cotangent, well, I probably should do some math to get this third side. So we're looking at 16 minus 9 is equal to question mark squared, which is going to be the square root of 7. Cotangent of the angle up here, so that's adjacent divided by opposite. Is going to be 3 over the square root of 7. If you feel the need to rationalize that denominator, we multiply the top and the bottom by the square root of 7. We get 3 square roots of 7 over 7.